or you can just use the angle between the two of them and use the sine.
Okay.
All right, so that's the force trying to, that's the torque trying to push it this way. What's that equal to?
Uh, 9.6.
Okay. What's the torque trying to push it the other way?
6. So the one on top would be 12,
Yep.
but the one pushing down, the one on top.
12 Newton meters going this way.
And since 9.6 is only 1 meter out, it's just going to stay 9.6.
Right.
So the one on top is going to be greater.
Yeah. So this will rotate this way with a torque of 2.4 Newton meters. Net torque, you know, 2.4 Newton meters. Okay.
I'm gonna write this.
Oh, this one down.
Okay.
You can add them and subtract them and everything, just like forces. Free body diagrams. So you can solve problems like that just by, all you gotta do is get the force and the moment arm perpendicular to each other and multiply them together. You add them up.
This all looks like it's based on torque.
Yeah, basically.
Okay. We've mentioned equilibrium a few times, right?
Yep. So,
I know one time you told me that there were 2 different kinds of equilibrium, right?
right.
Unstable and stable.
Those, so that's a different equilibrium. That's when we were talking about energy. So let me put this real quick.
So
you remember we had energy
okay.
charts?
Yeah.
These were stable equilibrium, these are unstable.
Yeah.
This is talking more about the force type of equilibrium. We had static and dynamic equilibrium. Do you remember those two? So if a box was sitting here, I had these forces acting on it. And it was in equilibrium. What does that mean about all those forces?
Yeah, equal 0.
Right. If it was in static equilibrium, what does it mean about the box?
It's not moving.
Right. If it's dynamic equilibrium, what does it mean about the box?
It's moving. That's my guess.
Right. But it's not accelerating.
Okay.
So it moves at a constant velocity. So with equilibrium, static equilibrium means it's sitting still. And the net force equals 0. And dynamic equilibrium means it's moving at constant rate. And the net force is equal to 0. Okay? So real quick with torque, if it wasn't in equilibrium, what would happen?
It would accelerate.
Right. And what kind of acceleration would that be? It's just going around in a circle.
Constant.
It would be a constant
Rotational?
acceleration, but yeah, it'd be an angular acceleration. Okay. So if it's in static equilibrium, if you've got something out here and it's got a little force out here and then a bigger force right here, and they cancel each other out, those two torques, what's it mean? It's not going to rotate at all, right?
Right.
And the net torque is equal to 0. But then what if it's just spinning around at a constant speed?
It's dynamic equilibrium.
So it is rotating, but it's rotating at constant rate.
So no acceleration.
Yep. And the torque net is equal to what?
I'm not sure. It could be constant, or it could be 0. I'm not sure.
It's 0.
Okay.
So anytime you're in equilibrium, the torque and the force are 0.
Okay.
The net torque and force, they're always going to be 0. But if you're in static equilibrium, it's not moving at all. If you're in dynamic equilibrium, it's either rotating or moving in a straight line. Okay. So, well, not necessarily in a straight line, but it's just moving at a constant rate. Nope. It'll be moving in a straight line.
So here it says there's 3 different kinds of motion: rotational and transitional, which is moving in a straight line. And then it says there's also combination motion.
Right. So
that doesn't matter here.